The hard part, because people say, what happens to this? It's gone. It looks like you just substituted this value in, and what happened to this value? If this wasn't here, and somebody said, well, what's the integral from 0 to t of r of u du? It's just r of t minus r of 0. But if you say, what's the derivative of that? If you say, what's the derivative of that? This is a constant. This is a variable. So this doesn't affect the derivative. It's just this. Okay? Actually, yeah, it was sort of e. I had to do e of whatever, right? That. E of t minus e of 0. But now if I want the derivative of that, e of 0 is a constant, right? E of 0 is a constant. It doesn't affect it, right? This is 0. The derivative of e of t was just r of t, right? It's just this. If somebody asks you, what's the integral from a to t of f of, must use different variable, or f of u. W is much better. If you want to know that, well, it's whatever. We need to know antiderivative. But if somebody says, what's the derivative of that with respect to time, what is the derivative of that with respect to time?
Is that an A?
That's an A.
Where? Oh, f of t.
W is just a dummy variable. Dummy variable.
Oh, is A a constant?
What?
Is A a constant?
A is a constant. The letters at the beginning, you assume A, B, C, those are constant. It's not just T, it's f of t. No, if you want the derivative of that, it just depends on this. It just depends on that. Okay, that's all it depends on. It only depends on the function value, the upper limit there. We're going to look at it graphically. You're back to our eating function. Okay. I want you to think about what's affecting the rate of change now, because you can see this visually up here. This is the area. This is like the value of the function. It's whatever you started with plus, the area I'm adding on. As I'm adding on area, let's start here. So we're eating. When is the area going up the fastest? That's where it was going up the fastest. Now, unfortunately, I was changing the speed I was moving this. If I'm moving this at a constant rate, when is it going up the fastest? Right there, right? The rate that it's going up is just the value of the function at that particular value. The rate that the area is changing is this height right here. The rate that the area is changing is the value of the function at that particular point. Okay? The rate that the area is changing is the derivative of the integral. The derivative of the integral is the function itself at that value. Derivative of integral of this function is just this, f of x. The derivative with respect to x of this function is f of x. Derivative of integral is the function itself. The rate that this is changing, the rate the area is changing is the height of the function itself, right? Because as soon as here it's going at a fairly constant rate because the heights are mostly the same. It stops right there because the height is 0. It starts going up really fast there because the height gets more. And then as soon as it gets to here, the area starts going down, right? The rate, because the height is negative. Then it starts going back up because the height is positive. Then it starts going down because the height is negative. Derivative of integral is the function itself. If we write anything there, it doesn't matter. As long as you recognize this thing in here is just some dummy variable here. Well, let's do one with an x here. The derivative with respect to x from 3 to x here of f of, doesn't matter what you're using here is a dummy variable, m. dm. Okay? The derivative with respect to x. This has to be with respect to x where that's the variable, right? That's the variable. What is this going to be? F of x. Did this where I started matter? The rate of you eating didn't matter where you started measuring it, right? You started measuring at midnight or 3 o'clock or wherever. The rate is still the same. If I started that function later on, it doesn't matter, right? If I started this here, right, this rate's still going to be the same. The rate that this is changing, the actual amount is different, but the rate is still the same. That's where it stops. That's where it's going fastest. This is where it turns around. The actual amount is different, but the rate that the area is changing is the same. The area itself would be different, but the rate of change of that would be exactly the same. Are we okay with that?